Good morning all. It is just morning. We're just about coming up to midday. Welcome to this live stream presentation from the global headquarters of IMarEST in London. Welcome to those of you who are to the east of us and have stayed up a bit late to watch this presentation. Welcome to those to the west of us who might even be having an early start on Independence Day to watch us. Special welcome to seafarers, because last week was the day of the seafarer, so certainly worth mentioning that. And also it's the year of the engineer, so special welcome to engineers. We're going to talk to you this morning about what's behind human error. I only hesitated there because I realised it will be afternoon by the time I start talking to you properly. We'll be talking to you today about what's behind human error, and without giving away too much of the script, obviously it's the human element. We are presenting on behalf of the IMRS Human Element Working Group. There will be myself, Martin Shaw, presenting on it. There will be Vaughan Pomeroy, and there will be Claire Pekcan, who will be presenting as well. It's probably worth sort of putting a bit of context around the Human Element Working Group. We'll talk about it a bit later, but we tend to look at the human element from a sort of whole ship point of view. We don't just look at it from the people point of view, we look at it from the point of view of the technology, we look at it from the point of view of the organisations that are behind it. So we won't necessarily be talking very much about issues like navigation, because we feel our colleagues in the Nautical Institute are well on top of those sort of issues. But just to understand that we're talking about the whole organisation. Let me start with a very brief outline of the presentation. We'll talk a bit about progress, how things have been going over the last 50 years. I'll try not to take 50 years to talk about that. We'll talk a bit about the human error and also the results of the survey that we sent out recently. We will talk a bit about the human element. Claire will talk about the seafarer. Vaughan will talk about the technical side of things, and I'll talk about the organisation side of things. And we'll finish off with a brief advert for the human element working group. Let's start with talking about progress. This is a chart which Vaughan has very kindly provided us with, which shows annual loss rate per 100 ships going back to the 1980s. And you can see when you look at that trend, that the trend is downwards, which is clearly good news. You can see that there are peaks and troughs, and I would argue that we don't see just one continuous trend there. We see a number of different paradigms that we followed for periods of times until we've run out of steam on those paradigms, and then we've shifted to something different. So it's good to see that there are those that there is a downward trend. You can see, for example, in the 1980s there were some blips as we went through the sort of freight rate crisis. Then you can see that in the early 90s we had a sort of blip, and indeed you can see that in the 2005 sort of 2010 period there was a sort of uptick sort of thing. It is a good picture, except if you were to compare it with the aviation industry, the airline industry, the same frequency rate there would be giving you a major airline accident every 2 weeks. So opportunities to improve still exist. Opportunities to learn from aviation, particularly in the way of accident investigation, is another thing that we should be looking at, and we'll talk about later on. Moving on to the next one, this is a more specific incident trend coming from the tanker industry, and you can see this is absolute rather than relative. You can see the big peaks in the sort of late 70s, early 80s, the next peak in the early 1990s, and then you can see that as a result of a lot of effort in the tanker industry, you can see how incident rates dropped very dramatically to the sort of 2003-2004 level, and then bumped back up again for a variety of different reasons. Lots of debate about why that is. Partly it's due to there being more ships out there, I think partly it was due to the fact that there was a lot more new ships coming into the market, and possibly people weren't totally prepared for the new technology that was coming along. There was complexity and all of that, and I think we could also agree that in that sort of 1990 to 2004 period, people were only really interested in safety and pollution, whereas the environmental issues have come in along the way. So the focus is not quite the same as it was. All of the environmental issues have to be dealt with, but you know, it contributes to the complexity in the industry. I would argue, as I said, that there are different phases that we've gone through. The phase that I started in the industry in focused on hardware and competence. We made many changes to the design of ships, whether it be tankers to all aft accommodation, to inert gas, crude oil washing and the likes, whether it be improving strength in bulkers, whether it be improving stability on ro-ros. A lot of focus on those sort of things, and a lot of focus on STCW. But as with most of these things, they do run out of steam. They shouldn't be forgotten. We don't leave these things behind, and we continue to enhance hardware and we continue to enhance competence. But the phase that we moved into as a result of the sort of technology shift that we saw, the low freight rates, casualisation of labour, the race to the bottom and costs and the likes of that, weak compliance brought us to the next sort of phase, which is about procedures and human error. Let's talk a little bit about human error. Let's start with some survey results. We sent out a survey last week on a number of issues to do with the human element. This is an interim set of results. We've got about 40 or 50 responses so far. There's a lot of debate about statistical significance and so forth in that. But there's a few things I want to bring out in this. First one is 80% of incidents are caused by human error, and that is a very high response that agrees with that. We are all used to hearing that expression, 80% of incidents are caused by human error, and it's clear that that's clearly something that's in people's brain. The good news is that most people believe that accidents are avoidable, which is good. And the interesting slide is the one at the bottom, which says human error is a disciplinary issue, where while we got a majority that said it isn't, something like 1/3 of the respondents view discipline as a solution to human error. Now, human error covers a number of different sort of things, including where people do deliberately do something wrong. But that's quite a high number to be suggesting that discipline is the solution to human error. The procedures in human error sort of era that I was talking about started in the 90s. We had the introduction of ISM. ISM is about the creation of management systems. It's about accountability. It's about ensuring that you have the right resources, and most importantly, it's about investigation of incidents. And in that sort of period in the early 90s, we saw people focusing more on investigating incidents, generally at a higher level, just getting to the first sort of the first step of saying, well, it's human error, mechanical failure, and focusing on the immediate causes. In my view, in those days, the result of a lot of the incidents, fortunately, was to reinforce existing knowledge and practice, some of which had drifted out of the industry over a period of time. So the reduction in incidents that we saw in that 1990 to mid-2000 period was reinforced by incident investigations that reinforced earlier problems. Human error could be broken down into different types of human error: slips, lapses, mistakes, and violations. Violations being somebody has deliberately done something wrong and chosen to do something wrong. The others are less onerous. We all remember, I'm sure, the Swiss cheese model, which owes its existence to James Reason. The model is built around there being a number of barriers, and those barriers having holes in them. And when the holes in those barriers line up, then you end up with the hazard flowing through into becoming a loss or becoming an incident. It's fair to say that everybody recognises that particular drawing. Less people recognise that. In the original drawing on the original figure that James Reason put in his, I think his 1995 book about organisational incidents, this bit underneath was part of the story. And what you have is what we call the sharp end and the blunt end, and you have the flow through from unsafe acts, which may come from local workplace factors, whether they be technical factors, whether it be to do with the individual and his the influences on his life, or ultimately through to the real blunt end, the organisational factors. And it's an important point to remember that when we talk about human error, everybody talks about human error in the front line. What they don't remember is that human error exists at the blunt end as well. So people make errors when they design equipment, when they build equipment. People make errors when they create procedures, when they create models of operations and all the rest of that sort of stuff. So getting behind human error also means understanding that human error is more widespread than just the person in the front line, who is quite often the sort of first victim of the incident. An investigation requires a no blame or a just culture. If you don't have a no blame or a just culture, then you're not necessarily going to get all the information. People are not necessarily stand up and volunteer to be punished. So you need to have a no blame culture. And for many years, I believe we did have that. Let's look at another slide from our survey, which is bigger incidents have greater consequences, including criminal proceedings, which is, large number of our audience believe this is the case, which then says, how can you have a just culture if bigger incidents are leading to criminal proceedings? In other words, a person can make the same mistake, but depending on the outcome, will be dealt with differently. So you can either be subject to criminal proceedings, or alternatively, you can say, well, bad luck, you just learn something. And that leads to the criminalisation of seafarers. It leads to the issues that we've heard where the captains of Erica, Prestige, HEWG Spirit, Captain and Chief Officer, the Captain of Costa Concordia, and crew members of the Costa Concordia were subject to criminal proceedings and were in the case of the HEWG Spirit, two spent a couple of years away from their family because they weren't allowed to leave Korea, albeit there was limited lane attached to them because the ship was at anchor at the time. In another big case recently, despite the fact that ISM says that the ship owner or ship operator is clearly responsible for the ship, one ship owner listed themselves as one of the victims of something the captain had done, which is we have an adversarial culture in the media, law, politics, and this drives the need to find a guilty person. And we have a compensation culture which encourages ambulance chasing lawyers out there to look for the guilty parties. But blame is not a safety strategy. Blaming people is not going to improve your safety at all. It may do exactly the opposite. There is an inherent belief with the blame culture that what we have is perfect ships run by perfect procedures, and in the middle of it, we've got a bunch of people that we just don't know why they don't do what they're told. We need to move away from that sort of model to something slightly different. Sorry, something radically different. And remember, again, human error is not just at the sharp end; it is at the blunt end. Let's talk a bit about the human element. This is the definition of the human element that IMO uses. I'm not going to read it out. There's a couple of things that are worth highlighting. Complex multi-dimensional issue and the need to cooperate to address human element issues effectively. The human element is a massively misunderstood expression. It's used in many different ways. And if you look at our study here, you'll see that about 10%, about 15% of people believe that the definition of the human element is effectively that one on the left. So that definition that's been around since the early 2000s, only 15% of the survey respondents believe that is the definition of human element. The bulk of them believe it's about human error. And another number of them believe that it's just anything to do with people. And this is an unfortunate confusion. It's difficult to see how we can deal with it. But you will hear people in the public domain making speeches and talking about the human element, when actually they just mean people. We've got to think about the human element. It's not the same as we've got to think about people involved in the human element. It means something quite dramatically different. So we are facing a big problem at the moment in that people are not all viewing the human element the same way. We are working with a group of NGOs at IMO, sorry for all the acronyms, who have taken it upon themselves to reinforce that 2003 view of the human element, which I'm quite hopeful will achieve some success in. If you go back to that definition, what does it say? It says actually it's about everything, it's all connected up, which is kind of a broad definition. But let's look at a model. This is a thing called the Septagon, which comes from a book called Human Factors in the Maritime Domain, written by Thomas Koster and Michel Gresh. And it's interesting because it shows you 7 different points, 7 different areas that all connect together. And if you think about the presentation that we're doing here, Claire will be talking about the individual, the seafarer. Vaughan will be talking about technology, physical environment, that sort of stuff. I'll be talking about the organisational environment, society and culture, and all those sort of things. But all of those things come together to determine what's happening day to day on a ship, in an organisation, and indeed all around us. We did think about simplifying it and coming up with a quadrigon, and we discussed that for a while before we realised we were talking about square. Moving back to our industry phases, my argument is we go through phases and each phase brings an improvement. We had the hardware and competence phase, we had the process and human error phase. We're now into the human element phase. And I would argue we've been into the human element phase for probably about 10 years. But we haven't got that far with it, in my view. We have seen, for example, excellent studies that Martha studied on fatigue. We've seen some understanding of human factors when it comes to investigations. We've seen a bit of understanding about workloads in the wider environment, but not a lot on the technical front, which Vaughan will talk about. We've not seen human-centered design, for example, taking over as a major sort of initiative. So, I guess the question we ask ourselves is whether we're in this world of perfect procedures, perfect ships, but there's somebody who comes along and screws it all up. Or are we looking at something different, where we have the seafarer trying to wrestle the technical factors and the organisational factors and sort of pull them into line as they gradually pull him apart? You know, are we heading towards a world where we understand that, in fact, that the only reason anything happens on board a ship is because of the people, rather than them being somebody who spends their entire life sitting around waiting to cause an incident? So, to me, this is the core of what we're going to talk about. And I'll now pass the button over to Claire, who will talk about the seafarer.
Good afternoon, everybody. I'm going to talk about seafarer and following along the lines of what's behind human error. But before I start getting into some of the explanations that are given for human error, I wanted to refresh our minds about the impact on seafarers themselves. We often report total constructive losses, and we know about how many ships we lose, but do we really know how many seafarers we actually lose? And these are some figures. Some of them are a bit dated now, going back to 2005 for the UK figures. But back in 2005, seafarers' mortality was nearly 30 times higher than the general working population, which is a huge number. And more recent figures from the Danish administration or Danish researchers shows that there's still 6 times more likely to die at work than workers ashore. And in a telemedicine database conducted a bunch of researchers, a group of researchers from America, found that 30% of the seafarers in this database in a 3-year period had an accident. So there's significant numbers of people being maimed and killed. And I think we need to remember that fact, that why would people make mistakes when these are the likely consequences, or some of the consequences? So I'm going to look now, before I move on, there's not only the harm to people physically, there's also the mental harm that we are doing to our seafarers. And I'm asking the question, are some of these things like high levels of stress, cirrhosis of the liver, being overweight, morbidly overweight, more likely to take your own life, and some diseases that you might experience in later life as a result of working at sea? Are these the harm that seafarers cause themselves because they can't cope with the working conditions and the situations that they're put in? So I think we need to think about some of those explanations too. In this slide, what I'm doing is talking about some of the common explanations for why we have human error. So we have competence is used to explain why people don't comply with rules and regulations, wearing a PPE, following procedures, they're incompetent. When it comes to unsafe behaviour, which is often a precursor to an accident, is we talk about seafarers being complacent, complacency slipping in, people aren't motivated to do the right thing, they take shortcuts, they bend the rules, or is there some other underlying factor behind seafarers' unsafe behaviour? And the last one, sorry, apologies, the purple hexagon, says commitment. And a seafarer is no longer as committed as they once were, which leads to a poor safety culture. And what I mean by safety culture is sorts of behaviours that help an organisation remain safe. So things like training new crew members on board, looking out for your fellow crew members by making sure that they wear their protective equipment, and also reporting violations and whistleblowing, which might lead to a better, safer environment. So I'm going to look at some of the explanations that are given, and I might probably argue that they're based on a lot on anecdote and not really on research. So some of the common things I hear are standards of training are not as good as the past. There's a lack of mentoring and knowledge sharing from seniors to juniors, but is that a motivational issue, or is it they just don't have the time to do it anymore? There's no sea sense in the young generation, they don't have any awareness about them, and a lack of investment by companies. And I do know that some companies that I've been working with probably invest less than 1% in their training budget of their turnover for a ship. Where I think probably the health and safety executives, certainly for shoreside industries, would be looking at a 5% investment to maintain a good, safe level of competence. Then what about unsafe behaviour? Is it all about complacency? Is there no longer a pride in the job? People no longer are proud to call themselves a seafarer, so they have a devil-may-care attitude? Do they lack professionalism nowadays? Are they apathetic? Are they lazy, irresponsible? Do they lack common sense? These are all the terms that I hear bandied about when when individuals are involved in an accident and people trying to find what happened, these are some of the explanations they automatically resort to. And what about safety culture, about looking after for your fellow members on board? Is it because seafaring's become a job? You just go there to earn money, it's no longer a career? Is that the reason why we have a lack of safety culture? Or are the new generation more mercenary than previous generations? Or are they, it's something I've heard when it comes to talking about fatigue, that seafarers already cosseted too much. We shouldn't be thinking about doing that sort of thing. And in my day, we did this, we worked harder, longer, so on and so forth. But I want to bring your attention to some other explanations. I've been involved with Mike Barnett, whose photo that you see there when he was a chief officer of war tankers, looking very exhausted. We've been looking at fatigue. So is it about the capacity to be safe? And that graph on your left-hand side is a trace from an ActiWatch, which is a device that records people's sleep and wake patterns. And this is a master on board a ship who you can see is not very active. And those bars are probably just a few hours long, the pink sections, indicating that they don't really get solid amounts of sleep. It's very fragmented, and certainly the other findings we received was that a lot of masters feel very stressed by the end of their voyage, and that may be the cause. Or is it poor morale? I did a PhD last year, I completed, and one of the things that I asked the seafarers that I studied was to say to me, I gave them a list of adjectives that describe feelings and asked them to indicate to what extent they'd felt these feelings over the previous 2 weeks while on board. The colours, the key there isn't very visible, but the sort of aqua colour, I suppose, sort of greeny blue colour, that is they never experience those. I have to remind myself, I think the orange is some of the time and the purple is occasionally. So the green one's never. So the big one in the middle, I asked them how much of the time do they feel miserable. And you can see that the majority never do. But if you add up all the ones that occasionally, some of the time, much of the time, there's a significant number who feel miserable at least some of the time they're on board. And if you think that the miserable, the proportion that said they were miserable all of the time was, I think, was about 3%. Out of 750 seafarers, that's 21 people. And we are talking about people. We're not talking about commodities. Tense and worried, a lot of them experience worry and tense, and how is that going to affect their concentration and things like that? So again, is it about these other things, competence and complacency, or is it about their emotional well-being? And the last one I'm going to look at as an alternative explanation for human error is poor leadership. This is an unpublished study that we did with ship's officers. And we asked them to fill in a psychometric test that looked at something called leadership judgment. So that's using the right form of leadership according to the circumstances, the people, and the amount of information that you have, the amount of knowledge you have yourself. And what we can see, and they're only small numbers, so they're only indicative, that captains are more likely to lead in a consultative manner, so they'll get the information, then make the decision. Chief engineers, very directive, so they are giving all the instructions, they're telling people to go and find the information for them, and they make decisions. And then the managers are sure, a combination of directive and consultative, which still means that they're making all the decisions. And this is what we call power culture. And what I want to draw your attention to is the other two bars, the green one and the pink one, which are consensual and delegation. These are about empowerment. These are about helping people develop the skills so that they can be effective in their job, but also take over from them, enable themselves to develop into the new positions. And what we see across the piece there for the management, both on the ship and shores, that is a considerably weak area of leadership expertise in the shipping industry. Again, it's only indicative, but my sense is that it's probably replicated in a number of organisations, not just the one we were studying. So coming now to what are we doing at HEWG about person in the piece. Well, we're going to be looking at the impact of new technologies and changing skill sets. And the photo there is courtesy of the Sea Traffic Management Project. And this is a project that's trying to streamline port turnaround times and things like that by having new navigational technologies and port decision-making algorithms to make things more efficient. But we need to think about, we don't want to make the same mistakes. You know, if we're going to be going down this road of autonomous ships, shore-controlled ships, we need to think about the consequences this has for the people. What sort of people are we going to have on? Are we going to have highly skilled teams that can deal with the technology, or are we going to have low-skilled workforce in few numbers, and and run the risk that we're going to have even more mental health issues for our seafarers? So those are some things that we're planning to look at and some projects that we've got ongoing at the moment. But now I'm done. Thank you for listening. I'm going to hand over to Vaughan. He's going to talk to you about technology.
Thanks, Claire. Technology, of course, historically this institute has always been involved in the wonderful engineering and so forth. There are lots of papers in our archives about how wonderful engineering is. Very few about what the people do with it. And so what I'm going to talk about is how the people interact with the technology and how we have to look at that in this modern world. Claire's just mentioned the elephant in the room, autonomous ships and what that might have. But of course, it doesn't matter where the technology is and where the people are. And if you look at the definition again of the human element, it's a life cycle. So we're talking about people who are designers, people who are installers, people who are builders, and people who operate. Now, when we started looking at what the human element technology links are, there is a number of common themes. Human-centeredness in design is something quite foreign to the industry. We know we're putting more and more layers of automation between the people and the things they control, and that is creating a certain barrier to the transmission of the information you used to feel by walking around and touching things. You're now remote from that. So we have to find some way of doing that. It's difficult to transmit the smells of an engine to the control. It's a wonderful AI project or something. If we could do that, and you have a sort of sensory experience in this 3D world that's projected in your control room somewhere remote from a ship, it would be rather clever. But it doesn't happen. As the systems we know are becoming much more complex, because we can make them more complex, and by making them more complex we can improve efficiency and so forth. Information intensity is causing real challenges to people, not least of which is in things like alarm handling. Alarm handling should be pretty simple, but the number of alarms that come up with no priority and so we could do a lot better if we designed alarm situations to be much more focused on how the user actually can use them. And Martin's mentioned dealing with the technical issues, resolving incidents, how they happen, looking at causes. It's becoming much more difficult because of the complexity of the systems. And one of the things that never really happens in a lot of cases is reaching down to what the fundamental underlying reasons were. You can get things up and running again, substitute, replace, whatever. Because one of the things we have found is, of course, the failure rates of some components that are now critical are too high. Come back to that in a minute. So there's lots of technology coming on. We've moved from things where we took dials off machines and put them in a control room. We then sort of put computers in the way. We've now got very sophisticated control rooms. And of course, marine engineers deal with this stuff that goes on the bridge. So although we probably are distancing ourselves a bit in this presentation from navigators and navigational error. We do provide the kit that they use, and there is an interface issue with some of that. But it isn't just about the seafarer. There are things here, this looks really at things that would be reported as hull structural failure, machinery failure, and yet really they're all to do with people somewhere through the life cycle. Somebody got something wrong, somebody made a misjudgment, somebody specified something wrong. If you can break a ship in two when it's sitting in the lock, there's something wrong. And it's probably not a lot to do with the seafarer, or it could be. When the side falls out of a bulk carrier, when bits of machinery go flying around the engine room, it isn't just the seafarer, there are people all the way through this chain who have a role to play. And when we look at the reliability of equipment, we did a very quick look at some current ships and compared with them a couple of studies which go back to probably the 70s. And the strange thing was the number of defects causing main engines to stop is surprisingly unchanged. Now, you wouldn't believe that if you read all the technical papers about main engines. So, the difference is that 30% of those are caused by sensor failure. When you go to an autonomous or remotely operated ship with more sensors, make your own judgment. We haven't developed the technology to be as robust as it should be if we're going to rely on some of these things. And we have got a mismatch between things we rely on and things that are there for an advisory purpose. One of the most significant probably is these systems which are there as advisors in the case of emergency. I design it as an advisory system, don't necessarily trust it entirely. What do? You've got an emergency system and this is giving you some advice. It's a hard call to say, well, it's only there for advice, I don't believe it. So we have a mismatch between these. We are also in a way down the path of drifting towards a dependence on digital systems. We're not going to get away from that, and yet some of the systems we put in are perhaps not designed to the level of integrity they should be, or the level of dependability. Simple means a comparison. Are we really a complex industry or are we simple? Have we really got low-tech ships that we run in a low-tech way because we think we've got simple things out there, we can run them as simple operations? So let's look at a very simple comparison, lines of source code. Well, where do you think the ship fits on that? It's obviously somewhere down the very simple. Except that, no it isn't. We've probably got as many lines of code on a modern simple ship as there is in the Boeing Dreamliner, maybe. So they are complex, and it isn't all designed with the same level of integrity that we might wish it was. So having decided that Martin showed you shipping is a complex business, in a book some years ago, Charles Perrow talking about normal accidents, coming up with the idea that actually in all complex industries there will be a normal level of accident. A number of people have come up with these sorts of curves that say there is a bottom level at which you can get where people are going to get in the way. And he defines shipping as being a complex industry, largely because, as Martin showed you, there's too many people, too many participants in the game who make it complex. I would argue that actually the technology is not quite as simple and straightforward as we might like to believe. We keep adding new solutions, so problem, add a new solution. Add something else, so we're making that ship more complex, for good reasons perhaps. Digital technologies have crept up on us as they have on many people. We've added them, they add bonuses, they're more flexible, they're easier to change, aren't they? You can go in, we can mod a few bits of data, but the adoption is largely unstructured. And some of those systems that are actually safety related are perhaps not as robust as we might like. they haven't been through the verification we might like, and that is an issue. There's a requirement in ISM that says training matches the ship. And I guess that's probably always been a challenge. It's certainly a challenge now, and it's made worse because there's a lack of standardisation. So if you think in terms of transferring from airliner to airliner, it's a problem. If you go Boeing to Airbus, it's not so much a problem. You go from A320 to A340 to A380. So standardisation is an issue we probably do need to consider and look at how that affects. So what can we do? What are we trying to do? Well, we're trying to look at the evidence base, because Martin mentioned 80% human error. I throw an argument around it, so actually I think most incidents have got people involved somewhere to a greater or lesser extent. So I start from 100 and work down. There are very few failures these days which can't be nailed on some person somewhere down the supply chain. So let's look at the evidence base and see what's really out there. What is going wrong? What are the common factors? What are the things where you can make a difference by doing something positive? Then looking at how we educate people and encourage them to look at a human-centered approach right the way through that life cycle, from design, perhaps from specification actually upwards. And then try and build some case studies that we can put out into this wide world to support education and training, to support that whole process. And a lot of this is about education rather than just training. Somehow you've got to get it back into the people that do go into design and manufacture, because they're a bigger player. And then provide the support that goes with that to the seafarers and the operators. So that's what we're trying to do, and I'll hand back to Martin to talk about how the organisation will be all together.
So, going back to where we started, we had the seafarer, we had the technology and the organisation, and the interplay between those three things determines how a ship is going to operate. From an organisation point of view, there's a number of things you have to think about. The organisation creates the mindset aboard, it creates the way the ship works and the way the people work on board it. Organisations can create goal conflicts and or fail to manage goal conflicts. So it's the most well-known of these is the conflict between safety and profitability. There's always a conflict between how much money you can spend on safety, and also from a commercial point of view, you have commercial pressure on the ship. So people will aim to get the ship in and out in a particular time. Will aim to sail potentially at 8 at night when people are tired and the likes of that. So there are a whole lot of goal conflicts, as I think I mentioned earlier. There's conflict between the environment and safety, security and safety, and those are all conflicts that need to be resolved by the organisation and not left to the person on board the ship to sort out themselves. The organisation, going right the way up to the regulatory organisation as well, determine a lot of the workload that is on board ship. And there is an issue between whether there's enough time on board, or enough people on board to complete the workload according to all the procedures that are available. That plays into complexity. Complexity means that it becomes quite opaque to the people on board what really is required and what people are expected to achieve in their day's work. And increasingly, we're seeing complex incidents which are easy to investigate but very difficult to anticipate. It's always easy looking backwards to see what went wrong, but looking forwards it's not quite as easy. We have blame and we have reward. We have motivational systems that motivate people based on KPIs which may be inappropriate and can actually drive the system in a particular direction that you don't want it to go. As Claire has mentioned, there's demotivation. People become uncomfortable with the environment they're working in and feel disempowered. They feel that they don't have any control over their life. As we all know, we like to have control over our lives. If we don't have any control, then we become intensely demotivated. How does it feel on board? Here's my Captain McAvitar, I call him. I'm stuck in the middle. He has to deal with conflicting goals. He's got to deal with the his priorities being safety, emissions, greenhouse gases, piracy, security, making money, doing things quicker, ballast water treatment, doing the paperwork. He's got conflicting requirements that come from the owner, the charter, the flag state, the port state, terminal rules and regs, QA system, chartering accounts, purchasing department procedures. He's got all of these things sort of piled in on top of him. He has to answer communications from the office through email about budgets, planned maintenance, spare gear in stores, risk assessments, incident reports, near misses and port and cargo information. And he's got to deal with a whole load of systems, ISO 9000, 14001, etc., etc. And you can see that clearly this is a complex world that he lives in. Do we live in a complex industry? You would think, looking at the industry, it's relatively straightforward. You have IMO, you have flag states, you have the recognised organisations, the class societies, down to the shipping company. The shipping company's role is pretty straightforward. It's got to operate ships, maintain ships, and do the design, not necessarily build. That's somebody else's job. And they need to interact with ports as they go in and out of port to make sure that they're following all the rules. Straightforward until you think that there's 170 different member states in IMO. Some of them are shipbuilding countries, some of them are ship-owning countries, some of them are neither. Some are major importers, some are major exporters, some of them are neither. So there's a whole different set of priorities that come to the fore. You have something like 30 plus different recognised organisations who have slightly different spins on what's going on. Thousands of shipping companies, tens of thousands of ships. And on top of that, you have a variety of industry organisations. You have IACs who represent the classification societies. You've got the Chamber of Shipping who produce guides on how to do things. This is primarily focused on the oil industry. You have OCIMF who produce large numbers of guides. And you have the insurance industry who produce casualty information that go right into the public domain. Way back in the sort of 70s and 80s, the port states became concerned about the fact that the flag states and classification societies weren't doing what they thought they should be doing, and decided they needed to build another level of regulation onto it. So they came up with port states. So port state allows port state surveyors to go aboard ships, inspect them, detain them if necessary, and to leverage up that power, they created memorandums of understanding. And those memorandums of understanding have become a major part of how the system runs. They produce regular white lists and black lists of flags and class societies, and encourage those flags and class societies to lift their game if they feel that they have to. They put a lot of information into the public domain, and they target. So if you're on a flag that is on the targeting list by an MOU, then expect to get lots of friendly visits as you go into ports in various different countries. So that's become a part of the structure over the last 10 or 15 years. This being an oil company slide to some degree, you also have the creation of vetting organisations and SIRE and all the rest of that sort of stuff. So you have ship inspections being carried out by oil companies. You have vetting organisations and lots of communications between shipping companies and vetting organisations. And in the middle of that, you have the trader, the oil trader, who said, well, actually, I'm not sure I want to be involved in all of this sort of stuff. So just warrant to me when your ship comes in that it's got 6 oil major acceptabilities, and that'll be fine for me. Now, this covers purely the tanker industry. It covers safety and oil pollution. If you try to overlay on that wider environmental legislation, security, piracy, MLC, and all the rest of that, then this would just be black. The slide would be completely opaque. You wouldn't be able to see anything. So, we have a complex industry, and it's complex because there are a lot of different people in it, all of whom have their own roles, and in many cases have the power to enforce their own roles. Procedures. We hear a lot about procedures. This is a slide from our survey. And the slide says that something like 45% of the people surveyed said that procedures must be followed precisely to avoid human error. The remaining group of people either said I don't agree, or in actual fact said sometimes procedures cannot be followed precisely as given. So procedures are important. You've got to make sure that they cover the risks, but you've also got to be careful that you don't compromise too much in making sure that, for example, liability issues are covered in procedures, that you lose sight of what you're trying to do. Let me talk very briefly about the Human Element Working Group in IMRS. This is our advert. I've shown you earlier where I think the industry is sort of going at the moment. The future, from our point of view, is looking at things like resilience. Resilience engineering is a subject that we hear more and more about, and also the human contribution. And the human contribution is to some degree the flip side of human error, and that is, without humans on board ships, nothing would happen. It's how do you recognise the fact that people are doing extremely good things to avoid accidents and to deal with the imperfect world that they have to work in, where there are not perfect ships, there are not perfect procedures, and not perfect management systems. In our little group, we're looking at moving ourselves from today's world, which focuses on procedures and human errors, to a greater understanding of the human element, and eventually towards this resilient shipping approach to things. And we look at it through three pillars, as it were. We look at the seafarer, the organisation, and technology. And we have a number of projects which you can see on the board there, which we're working on. Let's move on to the conclusions. As we pointed out at the beginning, not all bad news. Safety has improved over 50 years. Could do better would be the school teachers' sort of annotation in the margin. Can we learn more from aviation? We can. We've got to be careful what we learn from aviation. There are differences between ships and planes. So the difference between a ship and plane, to me, is the difference between what I call Bernie and Archie. Archie is Archimedes. Archimedes is about ships float. If the engine stops on the ship, it stays floating. Bernoulli is about how planes operate. If the engines stop on the plane crashes. So there are differences and we need to recognise them. But one of the things that we can learn from aviation is the way that they investigate incidents and get behind just the frontline human error. The focus in our industry has been on procedures and human error. We need to move it more towards the human element, and that means a greater understanding of the seafarer, as Claire has mentioned, a greater understanding of the technical issues, as Vaughan has mentioned, and the organisation, as I've just covered. And plug for the Human Element Working Group in IMRS. We're doing lots of good things. Come and join us if you want. That was the advert done. And I think that is us in terms of the presentation is concerned. Are there any questions? Yep.
I've got a couple of questions, as is my one. You showed the slide of Captain McAvitar and all the conflicting goals and requirements that are placed on it. I found that really interesting. I made me think, if it was and you mentioned aviation, if that was an airline pilot sitting in the middle, would he have the same quantity of different requirements and goals? I know there are different stakeholders involved, and an airline pilot isn't directly equivalent to the responsibilities of a captain. But I just wondered if you could maybe comment on that.
I thought, and then I'm going to throw the question to you as well, because I think you know more about aviation industry. But from my point of view, I would say the difference is there is a different segregation of duties. So from the point of view of the airline industry, the pilot has got nothing to do with maintenance. So maintenance isn't part of the piece that he has to deal with. The sort of ramp loading the passengers, for example, he doesn't have to load the passengers, so the cargo operations bit doesn't have to be dealt with by him. But I imagine it's handled in a different way. Did you want to? If you're going to speak, you need to stand in front of them.
I would just say,
I'm wary of the dangers of
Well,
drawing
there is a
comparisons.
danger, but there are things that are similar. Of course, you know, what you do find is that captains on aircraft are faced with a manifest, they sign off. So they sort of sign off for the loading, which is done by, you know, a baggage handling, cargo handling company. So when you talk with the airline captains, they say, well, yeah, you get presented with this thing and you sign it off. So there are some similarities that we perhaps don't immediately think of. But I think the thing that I noticed, I started by working in life a long time ago in the aircraft, was that throughout the whole of the life cycle, people know this thing called gravity. You know, Isaac Newton had been trying to be beaten for all your career. Otherwise, so you're very well aware in a design office when you're manufacturing that, you know, this is 1970. You put your hand up and say, I've tightened this little nut up too far and I've broken the bolt. And the culture was that you did that. You did not cover things up. And I think some of those things are fundamentally different. But there are some strange common themes. People do look at this, and of course they're moving into having something the equivalent of ISA rather later than shipping. I'm beginning to say, oh, that's interesting because we're not there yet, and it's not very integrated. So they haven't got this umbrella of ISM equivalent which covers a whole of the ship operation. They're still looking at a bit more compartmentalised between the maintenance, the operation and so forth. So there are areas where I think both could learn on each other. Don't know which is the biggest.
Yeah, in some respects, they might actually be going backwards and copying the shipping industry when it comes to the people management side of things. We've got this, you know, I'm no expert on aviation, this is just personal conceptions and opinions, but we've gone from the legacy airlines, haven't we? National carriers, and you know, we might draw comparisons with, you know, White Star Line or something like that, you know, of old, very old.
Track him out.
Where you probably stayed with your airline for your career. But now, we've got the low-cost airlines that have a more casualisation approach to their labour force. The crew may be not on permanent wages, they might be, you know, paid on an hourly rate and things like that. So, and they're beginning to get, you know, multinationals on board, and so all of the problems that come around not being able to communicate with one another and things like that, and the culture that you bring with you. I think they're starting to see more problems than they've had previously. And the other thing I would mention is the hours, you know, the fatigue issue. It's probably been a bigger issue in the aviation world because they are flying against their body clocks more frequently than seafarers might be. But and so that's their sort of nexus, their tension is their Achilles heel is over the flying hours. And what's happened in Europe is, I don't know what the number is, so let's say it's 1,200 flying hours per year is the maximum you can do. That used to be a maximum, it's now a target. So operators are insisting on getting more out of their workforce. And so, you know, maybe they are squeezing their safety in to a greater extent in the way that the shipping industry does with 6 on, 6 off and things.
Stephen, was there something you wanted to add to this?
Very quickly, I have a pilot's license, so I know a little bit about this subject. They're much better at near-miss reporting in the airline industry than we are in the shipping industry. That's just an observation.
But I think that's a cultural thing with, across the industry. I think
it's easier to do, I think.
Well, I think the consequence of not doing is you end up in a smoking hole. and so there is an incentive to do it. And I think, you know, as I say, it goes back to the factory. I still remember going in after one lunch and just twisting a bolt off. Well, I was strong in those days. And
You
the
had to leave
assumption,
the pub, hadn't you?
no, we didn't need to. We had a bar on the site. But you know, you twisted something off and you report it. So it's a very, very deep-seated culture that puts its hand up. And you know, pilots have reported, you know, I woke up and found my co-pilot also asleep. So we know there's a very different attitude. And I think the airlines maintain that. You know, the safety director is usually still flying, actually, because they maintain their hours. So it's a different way of doing things. You know, we don't send a lot of superintendents back to sea for 6 months to keep their hand in. And I think that there are these management, but Claire touched on fatigue. Because the cycle of duty is different, aviation has some similarities with truck driving rather than shipping. It's much more vulnerable to how long you've been awake before you start the duty cycle and time started counting. And if you look at the crash in the Hudson case, look where the pilot started his working cycle. He flew coach class from California to wherever he started, Pittsburgh or thereabouts, before he took the aircraft, Charleston. And that's quite normal. It doesn't count.
I like yourself, I have a lapsed pilot's license. Also the experience of landing a plane without an engine. Read about it in the accident investigation reports. And the training was something that really kicked in. But I think it kind of goes back to what we've been saying, and that is that in a light aircraft, single-engined aircraft, you get into that single-engined aircraft, you do your load sheets yourself. Or maybe you don't. Maybe you know that if you put 2 people in that plane and particular seats, that you're not going to have a problem. You check the fuel yourself. It's all, you don't do all that yourself, and then as the organisation gets bigger and bigger, there's more and more people involved. And as Vaughan said, eventually somebody somewhere has to sign off on that, and it's generally capped. Did you have? You said you had a couple of others.
I can keep asking questions as many as you
Yeah.
I don't know if you're getting any online. Or
Yeah, so you've had a question from one of our online viewers. Do you think that STCW is doing enough, and are states doing enough through port state control to enforce and implement current regulations?
STCW, do you want to?
No, well, the short answer is no, I don't think STCW does enough. It only makes passing reference to leadership and managerial skills. Although they're in there, they're like one line, you will manage well sort of thing. And a lot of industries have gone down the behavioural competency route, which is looking at how you behave, not just your technical understanding and experience that enables you to be technically competent, but also how you communicate to your colleagues, how you know, do you maintain the standards, do you show assertiveness and authority when required, are you able to be a mentor, and so on and so forth. And I think we need a more holistic view of what being competent means in the shipping industry. In order to prevent some things that happen. If you look at a lot of accidents, they're often not as a result of incompetence, they're often a skilled team, experience of the ship type, benign weather, yet they still have an accident. So one of the ones that's a real concern to me is entry into enclosed spaces, and there was an accident, I think, shown that, you know, even the captain went in the tank. And then you have to look at, well, how was this allowed to happen rather than why did they do what they did. You need to look at why people do things and not blame them for doing it, but how did they end up in that situation where that was the only course of action that they thought was the right? So to come back to STCW, no, it doesn't. And it's also probably out of date because technology is moving on at a pace. And is there enough in STCW that copes with or prepares people for a modern day ship? Probably not. So, yeah, a conundrum.
Yep. So I have a question for Claire.
Can we finish this?
Okay.
I just want to.
There was a second supplementary about port state control. STCW first. Does it come enough? It can't react fast enough to technology, and of course, if you put the standard courses together based on a particular technology, then you tend to sort of nail it in a point in history, and probably there needs to be a better way of dealing with those competence levels. I think with the port state control, it's much more interesting. There isn't a noticeable spike downwards in any of the incident data that suggests that port state control has made a significant difference, as far as I can see. Yeah, when you think of when port state control was brought in, there were another number of big initiatives running. We were stop and block carriers breaking into, disappearing, we were dealing with some of the Ro-Ro incidents and so forth, and you could see the old curve coming down and thinking we were doing all job well, and it kept on going down for a bit. Then it sort of bottomed out and bumbled along at around about 1 per 1,000 per year. And you would have thought as port state control came in and took out all those ships that shouldn't have been at sea, you would see it drop down lower than that, but it hasn't. And when you look at the other sort of data, which is machinery claims data and things that the underwriters will sometimes let you look at, all the data there is showing a nice steady climb upwards as the claims data goes up. Number of claims goes up, number of big claims goes up, total quantum goes up. And part of that is due to the very high costs of outage. So if you break a crankshaft and it takes you a year to get a new one, there's a very big off-hire claim and so forth. So there are factors like that that come in this, but the curve has definitely gone down and started climbing back up. And if port state control was going to take a lot of these things out, deal with them, you would have expected some sort of ripple effect or step in the data, and it just doesn't appear. However, you do see a lot of very bad ships tied up alongside. And so it ought to be taking out some of those ships that just were never going to survive. But it's an interesting thought. It's one that we probably ought to look at. I think it's had an effect, but it doesn't seem to come through in the outcome. It must come through in some data.
If I can add a bit to that, so I'll not make STCW, I agree with management and leadership stuff missing. The interesting point about that is the question was about is port state control doing enough? The port state control are not the people who are actually responsible for the ship. So ISN says the ship operator, the person who holds the document compliance, is responsible for the safety of the ship. And his flag state and his classification society are the people who are responsible for making sure that that ship complies with all the international legislation, class rules, and all the rest of that sort of stuff. Port state control is to some degree a check on what they're doing. One argument could be that port state control is influencing it indirectly because of the whitelists and the blacklists, because that is focusing people on the on flags that are less choosy, on making sure that they're doing things to a level that will allow them to escape from the black or the grey zone into the white zone. So there may be an indirect feedback mechanism, but again, I think it's an interesting thing to study. Could I just let you had a question?
Yeah, John Kutsoulos. I would like to ask Claire to tell us where did you get the sample for your investigation about the seafarers and the captains?
Morale or the leadership?
Everything. I mean.
Well, the leadership one was from cruise ship officers.
Only, yeah.
My PhD study was with 2 tanker companies. One was a ship
English flag or other type of flags?
Well, they were Danish and British registered, but I'm not sure which flag they were under. No, I wouldn't know. No, I can't remember off the top of my head. They were a Danish ship owning company and an British ship management company running tankers. So the workforce were majority, what you'd see in a lot of companies, Indian, Filipino, with a few Europeans in more senior positions. And interestingly, the Europeans, and this might be a cultural thing about reporting how you feel, were worse off in terms of emotional well-being than the Indians and Filipinos and so on. But as I say, that might just be that in those cultures you aren't actually honest about how you feel. Yeah, I did actually study 1,300 seafarers, but I was putting the graphs together. I just took I did a 2-shot sample. So yeah.
Okay, you something you wanted to say?
I was going to say, I mentioned on the port state control discussion that I've heard in conversation that the port state control officers are finding it increasingly difficult or challenging to actually perform inspections now because of the complexity of systems on board. ECDIS being the case in point, but this could apply as greater automation. How much can a spot check really reveal when problems lie further up the chain? So, another one for your ops.
Well, it's a sampling issue, isn't it?
It's a sampling issue, and you've got generally a port state inspector who is not necessarily able to deal with all stuff, and increasingly they're linked to checking safety equipment, fire, things like that. When you get into checking some of the complex integrated systems, it's a very specialist game.
Absolutely.
And you're not getting those sort of people doing those inspections. The class societies have specialist surveyors, and you need them. A lot of the flags, again, do not. And I think you have to have the right people if you're going to find things that don't work. The other one is finding out how the systems are being used. Because there was some work that the people at Cardiff did, which was looking at, I asked them years ago to look at the effectiveness of introducing new technology. It just happened to be that AIS was being introduced about then. So you actually had a step change, not just a sort of slightly upgraded version of what you'd been doing before. You could say, okay, this is new. What happened? And very quickly you found that it was being used for things that nobody intended. And it's being used in quite different ways. And some of them were probably error-inducing. So you were beginning to say, well, I've got this new toy. Goodness, I can do all sorts of things with this that nobody expected me to or intended to.
Radar assisted collisions.
Yeah, well, that's one, but this was even better. You could negotiate rights of way with the ship because you could identify the ship, make a direct ship-to-ship call, let's pass this way. Well, that's okay until something goes wrong. When the automatic reaction kicks in and you're away.
More years ago than I care to remember, I ran East Ship Vetting Service, and we had a the relationship with the Paris MOU. And it was quite interesting. Obviously, there's a whole wide range of things that they cover. They cover the SOAS, MARPOL, they cover all that sort of stuff. But the thing that they don't cover, and are not designed to cover, is operating practice. So the tanker industry operating practice comes from within the industry. ISGOT and all the rest of that sort of stuff. What the director of IMO describes as the gap between regulation and operation. So a lot of the, for example, in the tanker industry, a lot of the improvements came from driving those practices rather than from kicking the tires and from hardware. Claire, do you have another? Sorry, Katrina, do you have another question?
Yeah, another question from someone watching online. Do you think that the Swiss cheese model is still relevant, considering, as previously mentioned, some factors can't be foreseen and you can't put a barrier in place for something that you cannot see?
So, and I'll pass it out to others in a minute. So the Swiss cheese model was a really good start. I mean, for many years, it's been a vision that people have got in their mind, which is, there are barriers. You build some barriers. The more barriers you build, the better chance you have of avoiding that sort of instant sneaking through all the holes and all that stuff. So it's a good model. Other models are available. There are other models that have been developed, even to the most advanced ones that come from the resilience industry, called functional resonance assessment models and the likes of that sort of stuff. The key to it is to take it beyond the sharp end and start working your way down. Most of the models nowadays go from the immediate cause, which is to some degree what you picked up with the Swiss cheese model, and then start moving downwards into the technological factors or individual factors or organizational factors. So I think it's still quite a valuable model because it gives you a vision in your head of what you're trying to do. But you need to get below it. And if you go and talk to any IB, for example, you'll find that they're going a couple of levels down below that. You find most companies that have their own sort of facilities for investigating incidents are using a root cause analysis. Vaughan, do you want to come back into shot here and make some comments?
Well, I think you say about that. I think the Swiss cheese model is beautifully simple. And it says you have some sort of initiating event, some sort of nasty cause, and you can put various bits between it and stop it going from some hazardous situation to a nasty outcome. But it is a little bit simple, and there are more complex models, and I think probably even the creator of it would come up with something that's rather more sophisticated now. So, yeah, I would do something different.
Yeah, good point. One of Perrot's arguments was about the fact that things will fail in ways that we can't foresee. Because we've made it tightly coupled.
Stuff happens.
Yeah. and it's the same for procedures. Writing procedures, you can't write a procedure for every event that you're going to come across. So what do you do in those situations? Well, at the moment, we are reliant on our people, as well as the technology that's provided to them, but they have to be able to use it. And the route that the aviation world's going is looking at threat and error management rather than risk assessment and mitigation measures being put in place. So you will make mistakes, you will have threats, it's how well you manage them. And how well you manage them is down to your operational practices and the competence and the skills of your individuals, but thinking about that in a broader sense. And I think we don't do enough, as Stephen said, about near-miss, using near-miss information. They're free learning events. And I don't think in our industry that we really know what a near-miss is. We don't know how to record it. Seafarers don't know what they should put down. They put down everything from stubbing their toe to a major gas leak. you know, we need to get better at using this information because it is free learning opportunities. And being able to analyse trends and things like that. I think we've also got to get a lot more sophisticated, like the manufacturers do, about analysing what people are doing, basis. Because accidents are only the unforeseeable consequences of something somebody does. Somebody might do these behaviours time and time again, and it's just you know, sort of happenstance that they get caught out on this particular occasion. What we don't know, and what companies often don't look at, is what are people doing on a day-to-day basis that is unsafe? Working out, you know, measuring and monitoring people's performance. We don't do that in a very sophisticated way in the industry. So yeah, I think the Swiss cheese model, useful illustration for picturing what might happen, but I think we cannot predict. The person standing on the bridge of a ship that has the collision did not know they were going to have that collision.
They don't go to work intending to cause an accident.
Well, there's an incident trajectory, and what you're trying to do with the Swiss cheese model is to say that there is this sort of trajectory from something happening, and you can put things in place which sort of stop it progressing. And philosophically, that's what you're still trying to do. But what I guess the data we would really like to feed the work we're doing is we'd like to know how many times people stop that trajectory getting to the point you don't want to get to. And that data, it's a bit different to near-miss data because near-miss sort of implies, well, I really nearly got there, I just pulled it back, or something didn't quite get you over the last hurdle. But there's an awful lot of things between the initiating event and the final undesirable outcome, where people say, hey, something's moving, some temperature's got out of range, so we'll do something. Something's happened, we can do these things. You put in all sorts of corrective things which are usually people inputs. They may be automatic inputs or some, but things happen that aren't really the sort of barriers you put in a Swiss cheese model necessarily, but they are actions that reduce the severity of what the initiating causes. So there's all sorts of things you've got to look at, but essentially you're trying to control this trajectory. And the trajectory has probably got all sorts of little things that happen in the middle which accelerate it or decelerate it. So it's a complex path, and we tend to only look in an accident report at this bit at the end. So the trajectory may have started way back. There was a collision recently reported where the design of a bridge was curved in the Humber, and the pilot got a distorted view of
Didn't have the
the
central
course,
reference point anymore.
and there was a collision, and you think, well, okay, we've looked at that, but the trajectory started when somebody thought it was a jolly good idea to design it like that. And so, you know, how the Swiss cheese model works in that, I don't know. But there is this route that takes you from somebody's decision way back yonder to this ghastly mess we just got.
There's also the big issue of hindsight bias in investigations. Which is great. You know, you spend thousands of man hours in doing a complicated accident report, and you then look at it and you say to yourself, why on earth did that person make that decision? What could you possibly have been thinking about in a particular very expensive building tug, a very expensive incident I'm aware of. There was an investigation done, and it took 3 weeks to get to the point of understanding about a particular piece of equipment which had been installed by an expert from the company, And it took 3 weeks of investigation to find that a simple switch had been set in the wrong position, which completely changed the way that the system worked. If it took 3 weeks to find that out, there's no way the person on board the ship is going to understand that in the front line. In fact, there was a lot of discussions about the expert who turned out not to be necessarily the expert. In standing by a ship in Clyde many years ago, we got lots of experts who came along to tell us how things work. We came to the conclusion that an expert was a fitter who was willing to travel. Any more online? One,
Final one.
Yeah.
You've mentioned, in the discussion we touched on procedures a couple of times. The introduction of procedures and checklists into the shipping industry has generally been viewed as a good thing. But by doing that, are we in danger of almost trying to turn human seafarers into robots? And are we stepping stone to autonomous ships or something?
So I would say that procedures. So if you go back,
to risk losing initiative.
If you go back to my sort of curves, you go through a period of time, and then the law of diminishing returns hits. And I'm aware that having been in a company that dramatically reduced its accident rates, you get to a point where you think, geez, how do I get to the next step? And it all flattens out. And you potentially you can spend an awful lot of money to make a not very big sort of change. And I would argue that certainly in the tanker industry, where you see that 1990s down to 2002, 2003 reduction in incidents was to do with procedures. And it was to do with procedures bringing back the way tankers were supposed to be operated, because it had been lost somewhere in the 70s and 80s. But the industry had gone through some quite big changes. So what you did was you brought the procedures in, and actually the vetting systems you brought a compliance, not compliance, an enforcement mechanism in. So in the early days, you got all the knowledge that was out there codified in every of these systems. So you had a major drop down. But then when you get down to and when you investigate incidents, quite often you find lots of similar incidents. But when you get down to you're only having 1 or 2 incidents a year, and you feel obliged to create procedures to deal with those particular incidents, then you've hit the law of diminishing returns. So procedures, you need them, but they've not, they don't have to.
But the industry relies very heavily on procedural controls. So if you're looking at the way you mitigate hazards, the least effective way is procedure. And yet we tend to rely on those because they're cheap. They don't mean doing enough. It's a good thing. Torsional critical on the main engine. Notice on the control panel, don't operate it with these rates. Doesn't stop you doing it. And occasionally people do, and propellers fall off the back still. So there is a sort of mindset that says procedural controls is okay, but we know it's the least effective means of risk control. Are they bad? Not necessarily. And look back at the brief lectures of the American surgeon, Admiral Vaughan, and they put in checklists which have reduced their rates of error enormously. Now, there's a professional crew who checklist procedures, I don't know. But they've actually found if you have good checklists or good documented procedures, you reduce risk. So the question is not whether you have procedures and checklists, it's whether you have good ones.
Yeah, I was. The question seemed to be about this word professionalism, professional knowledge and understanding, competence and all that sort of thing. And I think, if there's a checklist and a procedure for everything, but they're not accessible, they take time to find, and they're not going to serve anybody well. And I think there has been this sort of creep facilitated by technology where you're getting micromanagement from shore. and the knee-jerk reaction to an incident is whacking another procedure, whacking another checklist, and it becomes an impossible burden on seafarers to actually do the job and comply with the checklist culture, the procedural culture, and some have said to me, captains have got it easy now. They just go on board, they're paid to do the job, and they go because the shore has started to take all the control and the responsibility, and so it's become, they're just
Something goes wrong.
yeah, exactly. Well, it's the whole de-skill upskill argument. If you de-skill people, whatever way, if you consider procedures a technology, if you de-skill people, you remove their ability to solve problems when there is no procedure checklist. Yeah, you do need to. Yeah, you take away their pride in their job, their sense of purpose and what they're doing, and so
a lot of companies are going through their procedures and through culling them. One company I remember seeing a presentation about this, 56,000 words of navigation procedures, which is now dropped down to 19,000 words. Albeit that they've worked with I can't remember what it was, SAS, the Norwegian airline, and their sort of consultancy arm to build checklists and all the rest of that followed an airline type model and did made a quite dramatic difference to the way of navigation and stuff. And a lot of companies are doing that. They say, well, we need to sort of start culling stuff. The great thing about Microsoft Word and Acrobat and all the rest of that sort of stuff was it made it incredibly easy to create procedures. They didn't make them any easier to read. You still had to spend the same amount of time per page.
yeah, badly written
So you need
procedures.
implants in your head, USB plug in the head.
Yeah, badly written procedures would be worse than no procedure.
Anything else?
Yeah, just I would like to comment that all the vessels now have a lot of procedures on board and a lot of manuals, which although may be technically correct, they don't take into consideration the human element. I mean, who is going to read? And I spent 30 years in American Bureau of Shipping, reviewing all these manuals and instructions, which, I mean, you take a lot of time to read them and understand them. I mean, I have seen people saying, just tell me what to do. I don't want to read it. And this is, the mentality nowadays. Tell me what to do. They don't take, time to read manuals and instructions.
Yeah. Well.
So if you tell them something wrong, they continue doing wrongly.
Yep.
I lost my thought now. I was going to say something. Well, it just shows how complicated and complex and intricate the industry is because that might be because we're no longer employing people from cadet to master, cadet to chief engineer, so that they learn the systems as they develop through the company. If we're working on a basis where we get a crewing agency to, we need a third mate on this ship or whatever, they don't have that ingrained company understanding of ways of working and the company's culture. So do we blame the individual because they're not competent? They should come with all these expertise, which is often an approach that's taken by the industry, is that they've got a certificate of competence. They should be competent. But that is just one part. And I think so the way you manage your workforce can have a huge implication on how safe they are in terms of how well they know your culture and your procedures and your way of operating.
And in some countries you pay for the certificate.
Yes.
In some countries you pay for the certificate, yeah.
Still going on. We're trying to get rid of that.
There'll always be something.
Are there any other questions? Anything else online?
Yeah, one last comment. Is it fair to say that process and procedure is somewhat used as sticking a plaster over experience and training, especially as from an automation perspective, it's just another means of adding deterministic behavior?
Oh, that was a good one to finish on.
Yes.
So it's very similar.
Yes.
Sticking plaster over training, is that the gist of
Yeah.
the question?
I would say the answer is probably yes. I think there is a tendency for people to feel that rather than invest money in training, right on procedure.
Well, as I said, in my limited experience, the amount that companies invest in training is well and truly enough. In terms of what they're expecting people to be able to do, and there's a drift into this. Bringing people back in their leave, which these are people, they're not going to be happy about doing that, and so they're not necessarily going to be in the right frame of mind to learn. And so that you have to look at how you manage your workforce. And obviously I'm very biased in that I'm a psychologist, but people management is the core to your safety. And training and investing in their skills is part of that process.
Vaughan, do you want to add it? Yeah. So I mean, the only thing I would add, and just to be slightly careful in what we're doing here, and that is to say that safety aboard ship is a balance. It's a balance between the technology, it's a balance between the organisational type of stuff, including the procedures. Procedures have a place, but they can go too far. And the seafarer, the individual side of things. And it's finding the right balance of all of those three things together that'll get things to work properly. So procedures have got a place. They're not just a sticking plaster. They have a place in taking that certificate of competency and allowing people to apply their knowledge to the ship. Any more? In that case, I think we better call a halt. Can I thank very much all of those in the room who asked lots of questions and those out there who asked lots of questions. And thank you to all of you online who've given up some of your time today to listen in to us talking. Thanks very much.
Thank you.